Alright, it's been a long time coming, so let's go ahead and jump into our third episode of our set implementation in Haskell. Last time we implemented a few basic commands like print, delete, and next, and just got a very rudimentary set implementation up and running. We haven't really done too much testing on it though, and it's not exactly beautiful in the way it looks right now either. So maybe we should start with just seeing kind of how our efficiency is. I'm going to jump over here and we can split screens. First I want a file that just has like maybe close to 10,000 lines of something that we can process. So I could do this and let's see, 2999 paste, so that's going to have 1,000 lines, and we'll just call this test. And then we can just filter it through regular sed like this, and if we wanted to time that, we can do so too. So sed is extremely fast, and I don't expect for our program to get down to 0.007 seconds on a 9,000 line file to process. Perhaps sed is actually checking to see if there's no commands and then just returning the file. I'm not exactly sure how it. Haven't looked through the source code that well, but I think we're going to see that our program is not nearly this efficient. So let's just try running this, and let's just put the time in front of it too, just to see. So clearly it's not under a second, and I can hear my CPU running up, and it's almost hanging. And I think this is probably going to be due to all of the list manipulation that we're doing. As you see here, we are turning these data text objects into lists, concatenating those lists, and then unlining them every single time that we print, which is every single line. And storing a lot of memory too. Wow, 25 seconds. 25 seconds. So that's pretty bad. So we need maybe a more efficient way to handle this. One way we could do this is we could make a kind of a concatenation command. Like, let's do something like this, and say it takes a t.text and a t.text, and it returns a t.text. And we'll say that A concatenated with B is going to be A appended to and appended to B, but we already know that this won't add our new line, so we can add the new line by doing a little construction with the new line on B, and that should work. And then we shouldn't need to unlines it either. So we can delete this, and we should just be able to kind of take the output and append it to the pattern space of SS, and doesn't that look prettier anyway? So let's try this and see if that makes any difference. 4 seconds, wow. So that made quite a difference. I think we did diagnose what the largest efficiency problem was right here. We probably have some other efficiency problems too that are contributing to this though as well. And one of my viewers in the last episode mentioned the idea of implementing a zipper in this program, and basically a zipper can be constructed out of another data type, but it's sort of like a linked list, but not really, but in the sense that it's only focused on one object at a time, and the cursor moves around, and so you don't have to manipulate on the entire object as you're working, and you can get some efficiency gains out of that. So let's see if we can't implement that. We'll just import a import a ListZipper since we're working with lists, and we'll import that as Z. And it also dawns on me that we kind of have two things here that are very similar, the input and the output. What if instead of keeping this input object at all times, we just kind of manipulated it and changed it as we're going along, and whatever the end result was ended up being the output. And that's really what sed's doing anyways. It's kind of filtering through and manipulating the std_in into a new std_out. So let's just comment out this input for a second and just keep the comment out the output and keep the input. And instead of a t.text, let's change this to a z.zipper t.text. So this will be a ListZipper, and that's going to cause some errors. Okay, the first of which is that we commented out output, and so that can't exist anymore. So we said we're going to manipulate the input and eventually return whatever's there. So we'll need to do the input here. Let's see here. Output is not visible. Okay. So we're not going to modify the output anymore. It doesn't exist. So we're going to modify the input. And basically we need to, instead of appending whatever's in the pattern space to the input, because the input is now a zipper, we need to insert whatever's in the pattern space into the input. So we could do kind of like this, z.insert whatever's in the pattern space into the input, like this. We also want to move the cursor when we do this though, and there's another zipper command called push that will do that. We'll insert it and then move the cursor to the right. Okay, so let's go ahead and do that, and then we got some more errors. One of which is that when we're constructing the sed state, we are giving it a output when we have deleted that. So let's get rid of that. And now it's expecting a zipper, but we're still giving it a t.text. So let's construct the zipper from the list that we're giving it. So we'll take a list of whatever the original input was, like this, and make a zipper out of it. And then we can put that right here, and there's our zipper. And instead of the head of t lines here, we can just do wherever the cursor starts off at, like this. It also dawns on me that the hold space doesn't really start out empty. It really starts as a new line. So let's go ahead and change that. If you've watched my other sed videos, then you understand that. So we'll change that too for now. Okay, and this is no longer going to work because we're trying to lines on a zipper. But this is one of the places that the zipper will make our code look nicer, because we can just say if we're at the end of the zipper, then we're done. And here we are returning a t.text because that's the end of our sed state, but we have a zipper instead. So we need to change this zipper into a t.text at the very end. And one way we can do that is change it to a list, but then it's a list instead of a t.text, so we also need to unlines that list. And that should resolve that issue. And then of course the next command, which will change quite a bit, I assume, because we are now going to be traversing the zipper instead of a list. So let's say that instead of, again, instead of linesing something, because this is still thinking it's a t.text, we can just take the cursor of wherever the zipper is at. So the zipper of input, like that. But we also need a way to traverse to the next line. which right now we are not doing it. So we need to create a new, or move the zipper along to the right. So we can do that by doing z right on the zipper. And we need a comma. Okay, that looks pretty good. So let's try taking that for a whirl. Wow. Wow, so now we're down to under a second with this zipper. So that did provide us some significant efficiency gains. However, we are seeing that now our program is outputting 2 copies of every test this out, and that's not really what we want. Just to make sure, let's try it with just test this out. And we also, as I thought, we are getting 3 tests at the beginning of our file. So really this should just say test this out instead of test this out. So something's going on here. And I think part of the reason for that is we are pushing new information into our input every time that we print, but we are not getting rid of the original information. So instead of using z right here, we can actually use z delete, and that will remove whatever is current and go to the right. So let's give that a try and see what that does. So now we're getting test this out, so we still have a problem at the very beginning. And I think that is because right here we are just starting out with the zipper, and again, this is much like our first next command, because we're making the pattern space into the cursor, which is what this line does, but we are not deleting the input of the first line when we pass in the zipper. So let's instead do a z delete z here, and now we are getting what we originally wanted, and a much faster program. So that provided us some significant efficiency gains, and we don't even really need to use this function, but we might need it later, because I assume there will be some point in which we need to append a couple of t.text, so we'll just leave that commented out for now. The only warning we have left now is use string instead of list of cars. I use this because I was going to use it as a flag command, but we can really do it with a string. I think we all know what a string is, so that's not too big of a problem. But we can go ahead and try and implement our substitute command too in this episode, since we're feeling adventurous and getting a lot done. So the substitute command is going to take a pattern and a replacement and some flags. And since the run command just takes a command, we need to close all that in parentheses so that it knows what we're talking about. And we'll just structure this like our other commands here. Okay. Then let's see. SS is going to equal SS. So basically, the substitute command is going to work on the pattern space. It's going to change the pattern space. So it needs to do something to the pattern space. And because we're specifying a pattern here, we're also going to need some way to do regex expressions. So let's go ahead and import the Text.Regex library as tr, and happen to know that the Text.Regex has a function called subregex, which takes a regex and an input string. So let's see. It takes a regex and it takes a pattern, an input string, and a replacement. So you can use the replacement here to specify things like \1 and \2, which will match submatches of your regex pattern. Okay, so let's think about this. Our pattern needs to be a regex pattern, so we can also use the tr library and make regex to convert whatever string we input it into an actual regex object. Then let's see, we have our pattern space, which is a t.text, but the sub-regex command takes strings. So we're going to have to turn that into a string. And this is going to be the pattern space, SS. And then finally, the replacement string is going to be whatever string we passed in. And we have an F here, but we are not doing flags yet because that's too complicated for this episode, so we'll just put an underscore there. But we have a problem. Couldn't match type string with text. Okay, so after all of this is done, what we have is a string, and the pattern space needs to be a t.text. So we need to pack back up whatever we did originally. And there we go. We can also clean this line up quite a bit. Let's just say let regex equal, and we can do all of this stuff in, and then we'll just pack the regex. And redundant, so we don't need that. Okay, and that looks nicer. I'm pretty pleased with that, but we still don't know if it actually works or not. So let's take it for a spin. So we need to substitute something. So we need a substitute command, and we'll have a pattern and a replacement string, and then the flags, which we'll just leave as an empty string for now since we're not using it. And let's just, don't think that's going to break anything. It should still run as it was before. Yep. And let's just do something easy, like let's change test to foo. And then all of the tests should be foos, which they are. And then let's try something more complicated, like let's say any line that starts with T, like test and this, will match a pattern afterwards. And then we'll put that matched pattern in the front and then end with a T. So it should say like hist and est because it's moving the T to the end of the line. And that did not work. And I assume it's probably because of this backslash. We actually need 2 backslashes because we want the actual string to have a \1. So let's try that. And that works too. So now we have working regex on our substitute. That seems like a pretty good place to stop on this episode. We made quite a bit of efficiency gains, and we added one of the most useful commands in SED, the substitute command. Of course, we don't have that much functionality yet, so we'll need to continue adding commands and continue to check on efficiency, and maybe eventually we need to figure out how to parse the actual SED syntax into these commands instead of having to type them explicitly. But that will all be in the future. I appreciate y'all's patience, and I thank you for watching, and I hope you have a great week. Let's go ahead and commit these changes. So we'll just do a git add u, and we'll say, ooh, you know what? It's probably better if we did this in chunks. So to fix this, we can reset this back, and we can add it with the p flag, which will allow us to patch what we're committing. And right now it's trying to stage the entire file. So instead of going through hunks, which is kind of annoying for me, I like to use E to edit it. And then you can just kind of delete the lines that you don't want in this commit. So I'll keep that the same and delete out the imported library, and then just delete out these lines where we implemented the substitute command, and leave the main function the same for now. and that will stage that, and we can look now and see that the only things that are staged to be committed are our changes implementing the zipper. So I'll commit that as implemented ListZipper for efficiency. Okay, and then we can just add the rest of the changes, and we can check that, and now it has all the substitute command stuff. So we will commit that as added substitute command. Added the substitute command, something like that. And then I can tag this as episode 3, and then I can push it to GitHub. Alright, thanks for watching. I'll see you on the next episode.